Good morning students. In today's class we are going to discuss zeros of a polynomial. To define the zeros of a polynomial, here let us take one polynomial. I have considered a polynomial that is x minus 2. This is a polynomial which having two terms here, isn't it? Now I am going to make this polynomial is equals to 0 by substituting some value in x here. Suppose if x is equals to 2, if I substitute in place of x 2, we'll see what will happen for the polynomial. P of 2 is equals to 2 minus 2, which is equals to 0. As I told, here we are getting a polynomial is equals to 0, isn't it? So the value x equals to 2 is called the 0 of the polynomial. Then value x equals to 2 is called what? A 0 of the given polynomial. If I put x equals to minus 2. If I put x equals to minus 2 in this polynomial means p of minus 2 is equals to minus 2 minus 2. Totally we are getting minus 4, right? So x equals to minus 2 is not 0 of the given polynomial. This is the one example to define 0 of the polynomial. We'll see some more example. We'll take one more example. P of x equals to 2x plus 3. Right? Here we'll put some value to make this polynomial is equals to 0 now. I'm going to put x is equals to minus 3 by 2. Right? Now P of minus 3 by 2 is equals to 2 into minus 3 by 2 plus 3. Isn't it? So 2 get cancels. Remaining is minus 3 plus 3. So again plus 3 minus 3 get cancels. Remaining is 0. Isn't it? So now x equals to minus 3 by 2 is the 0 of this polynomial. Okay. This is what zeros of a polynomial says. So let us define a definition for zeros of a polynomial in general. A zero definition. A zero of a polynomial of a polynomial p of x is a number, right? A zero polynomial is a number, right? It is a number. It is a number. A number means I am going to write it as a C. It is a one number, right? That number such that P of, when I substitute this number, that is this value. When I substitute this value, I have taken this value as a C here, right? When I substitute that value in the polynomial, we should get equals to 0, right? Then C is called here 0 of the polynomial. This is the general definition to say 0 of a polynomial. These are the two examples. You should write it in a notes. This is a definition to define the zeros of a polynomial. Next we will learn how to find. Here I have written, in generally I have taken that x equals to 2. Then how to find the 0 of the polynomial we'll learn. Here we'll learn how to find that x value. Okay. First we need to equate this p of x is equals to 0. Means I am going to write p of x is equals to 0 directly. Okay. We know the value of p of x, that is x minus 2 is equals to 0. Okay. Now I am going to leave this x here only. We will bring the constant to the right hand side, that is plus 2. Right. If I substitute this x value is equals to 2 in this polynomial means we are getting p of x equals to 0, isn't it? So this is how we need to find that 0. How to find that 0 means first we need to equate this p of x to the 0, then we need to find the value of x, right? Similarly here also, first we need to equate this polynomial to the 0, we'll substitute this polynomial here. P of x is 2x plus 3 is equals to 0. Then 2x is equals to, this is plus. I will bring it to the right hand side. It will be minus 3. Now the relation between the constant and the variable, that is multiplication. So minus 3 divided by 2. Isn't it? This value only we substituted in the previous problem. Yes or no? This is how we need to find the zeros of a polynomial. Right? There is no need to write these two examples in your notes. Now we'll write some notes. Note. In first two examples, we came to know that for a polynomial there exists a zero. Students, now will learn whether for non-constant zero polynomial zeros will exist or not. Okay. Non-zero constant polynomial means it is, we'll consider here polynomial which is non-zero but it is a constant. Okay. This is a constant and it is not zero. Isn't it? Such type of polynomials are called as here non-zero constant polynomial. Whether this type of polynomial will have 0 or not, we'll check. Okay. If I replace, you know that a constant will always having x raised to 0. Right. If I replace x by any number, if I replace x by any number means still I will be getting that constant only. Isn't it? So, we can say that a non-zero constant polynomial has no zeros. Okay. Therefore, non-constant zero polynomial will has no zeros. No zeros. Okay. So, we'll write first point. A non-constant, a non-zero constant polynomial has no zero. Right? That is, we can give this example for the note 1. Okay. This is example for the first note. Next we'll consider one more. Here we have considered non-zero constant polynomial. But now we'll consider one zero polynomial. We'll consider a zero polynomial. Okay. Zero polynomial means it will be also having x raised to 0. Okay. If I replace x by any number, means here I will be getting 0 only. Isn't it? So, we can say that this 0 is the 0 of the polynomial. 0 is the 0 of the polynomial here. So, we'll write here second point. For 0 polynomial, every real number. Okay, the second point is every real number is a 0 of the zero polynomial. This is the zero polynomial. If I substitute or replace x by any real number means it may be positive integer, negative integer, natural number, whole number. If I substitute any number in place of x, I will be getting 0 only. Isn't it? So, every real number is a 0 of the zero polynomial. This is the second example for the second point. Next we will solve exercise 4.2.